Okay, today's problem is unique k number sum. Difficulty is medium, and the accuracy, wow, I don't know if I've seen an accuracy that high, 81.44%. That's good because I'm not super confident. Well, I think the algorithm that we have will work, but it's slow. Given two integers n and k. The task is to find all combinations of k numbers that add up to n. Based on the following conditions, numbers from the range 1 to n are used. Every number can be used at most once. You can return the combinations in any order. The driver code will print them in sorted order. So we have a couple of examples here. If n were 9 and k were 3, there are three ways of assembling three unique numbers between 1 and 9 so that they add up to 9. And here they are. In this one, if n were 3 and k were 3, well, obviously there's no way to do that using unique numbers. If the only way to add three numbers up to 3 is 1, 1, 1, but we're not allowed to do that. They have to be distinct numbers. N is going to be between 1 and 50. K is between 1 and 9. Expected complexities. Okay, k times 2. K times 2 to the 9th. What is 2 to the 9th? Well, 2 to the 10th is about 1,000. So 2 to the 9th is like 512 times k. 945. Okay, so it's not an extraordinary number of operations, but it is, kind of a real brute force type of thing. But that's what it seems like they want: backtracking and recursion. All right, so yeah, we can do it with backtracking and recursion. Let's get this over a little bit. All right. Rather than passing k into the backtrack algorithm all the time, we're just going to set it up here. It's a constant. It's not going to change. K. That is k is the number of numbers that were allowed for each array. So we'll create our result array, and we'll create a second array that we will use to build up arrays to put into the result array. And then we'll start with calling the backtracking. What we're calling backtracking with is the target sum, the sum that we're trying to achieve, which initially is n. The start num, which initially is 1. And then the current array list and the result array list. All right. Here's our base case here. This is what we're trying to accomplish. We want to get the target sum to 0 at the same time that the current array list size is k. If we do that, then we can add the array list to the result and return. Now here is a failure case. If we get to where either the current size is greater than k, or the target sum is less than 0, and we haven't accomplished this, excuse me, this is a failure. We return, but we add nothing to the result. Otherwise, we backtrack. So, for example, we would come in here the first time with a target sum, and let's use this example here, a target sum of 9 and a start num of 1. All right, start num is 1, so we add that to the current array. Good. Then we call backtrack. Target sum, we're going to subtract I from the target sum, so it's not 9 anymore, it's 8. And we're going to increment the start num, which is now 2. Current and result, okay. And then, so if we backtrack, we come in here, target sum is now 8, start num is 2. neither of these if statements apply, I is 2. So we're going to add 2 to the current array. So now we have 1 and 2, and we're going to backtrack again. Subtract 2 from the target sum. Target sum is now 6. Start num is 3. Current and result, we go through again. What we're going to find is this doesn't apply, this if statement doesn't apply, and start num is, let's see, we are, 2, 8, 2, start num is 3, so we can add a 3, and then we can backtrack again. Now, at this point, what we're going to find is that we're going to try to add, 4, 5, 6, 7, 8. Now, those are all going to fail because the array size is going to be too big if we try to work with 1, 2, 3. In each case where backtrack returns, whether or not it succeeds or fails, we're going to remove the last element. So we'll go through and fail with all the 4 element arrays. And then since 1, 2, 3 didn't work, we'll try 1, 2, 4. That will fail. 1, 2, 5 will fail. Eventually 1, 2, 6 will work. Okay. And then we'll take the 6 off. We'll fail a few more times. Eventually we'll have failed all the ways we can fail with 1 and 2, and we will remove the 2 and put in a 3. Now, there is a way we can succeed with 1 and 3. The problem here with just a brute force array list, just a brute force recursion and backtracking is maybe it's going to time out. I don't know. Now, there are ways that you could prune search paths that are not going to work. It would be more complicated, and so I haven't done it, because if the simple kind of brute force way works, then I don't want to try to do it in a more complicated way. So anyway, here we go. Submit. Wow. Okay, so that worked. All right, yeah, so please go ahead and like the video. Subscribe to the channel, and we will see you next time.